Okay, welcome. Today's video by a technical technician from Diagnation, and basically today we're going to talk about AC cooling issues. And when I talk about AC cooling issues, I don't just mean if the car comes into you and the customer complains it's not cooling. This is more or less an intermittent cooling. The customer's driving the car and the cooling's working good. They got a good vent temperature, and a few miles down the road they're at a red light, and all of a sudden the air becomes cooler and the AC doesn't work for a few blocks, and then they move on again and the AC seems to come back. Something I guess we can also call this intermittent cooling. And issues like this, and we'll talk about things that can cause that here. As you look at your schematic, you can print this out. We're dealing with 4 channels here, 4 hookups. Channel A on the scope is the low side pressure test board. We got 100 psi transducer there. Channel B is power to the AC clutch. As you can see it, the power is supplied by the AC relay. You don't see that in the illustrator. You just see a hot feed or a positive feed going to the AC clutch. It also is grounded there. Channel C is the current ramp to the AC clutch. That is the green channel. And channel D, which you don't see the D, but unless it's the brown or gold channel, that is what we call the evap temperature sensor. That's a big important player that sometimes we overlook. That is on the passenger side or the driver's side of the firewall. It is a thermistor that's kind of pushed into the fins of the evaporator, and it sort of senses the temperature of the evaporator, as the name implies. It does not touch refrigerant. It's more pushed into the cooling fins of that. I guess you call that heat exchanger. Well, the evaporator is basically a heat exchanger, and it's hardwired back to the AC control unit. It's got a 5-volt reference and then a ground, and its voltage will change within the range of its how it's sensing the temperature. So nonetheless, be mindful of the AC control unit. That is networked to the PCM on the Honda, on the BCAN to the FCAN network, with the gauge control unit being the gateway. I've shot that in other network videos a few months ago, but nonetheless, the PCM has the ultimate control of the clutch, but it does so dependent on its input information, and the AC evap temperature is pretty important. So we're going to look at that on the scope, and you're going to see the voltage change slightly as the compressor comes on and off, where the temperature of the evaporator would be changing. So just be mindful of things. I have the scope captured. We have our camera here. We're going down to the scope. I have about a 90-second road test, which has been done. I went down the road, and we'll explain our captures here. We got the 4 channel scope, and we got 4 captures. In blue is the pressure. That's the low side pressure transducer connected to the low side. Basically, it's starting pressure with the AC not on. That's just the ambient pressure. That's about 51 psi. The temperature here in San Jose, it's about 57. It's pretty cool, but nonetheless, that usually is close to the ambient temperature when the car's been sitting for a while, and it sort of equalizes there. Channel B is the feed to the AC clutch. You can see it right here. It's not being fed yet. It'll get there eventually in the screen. About 3/4 of the way across the screen capture, the AC clutch engages. Channel, let me get to D, and I'll go to D, is that evaporated temperature sensor I was talking about. Be mindful of that thing. A lot of times vent temperature complaints could be related when this sensor gets skewed. I've seen it where you get temperature vent temperatures that just aren't up to snuff for the customer, and a lot of times this sensor could be skewed or not working or disconnected or have an internal failure in the sensor. So just be mindful of that sensor. And channel green C is the current ramp going to the AC clutch. I'll blow up that. This is when right here. So this is right here is when the AC decides to cycle on, or I probably turned it on. We can see we've got a nice pintle hump on green. We can see our AC compressor turn on and start to pump. Now the green channel is on the suction side, so obviously we want to see our pressure go down. That implies we got good pull. The AC compressor is pulling on the low side, actually pushing on the high side. Obviously we're not looking at the high side. We don't have a transducer on the high side, but we did, that pressure would be going up. So we got a good pintle hump here. The AC clutch is drawing about 2.8 amps. Now, be mindful of the gist of this video is for intermittent AC cooling issues. If we had a situation where we had power, where our red channel stayed high, we know we have a good feed right at the AC compressor clutch, and say something happened to the current, we lost current then, or current got lower or current got higher, that would tell us that the AC clutch may be shorting, it may be pulling too much amperage, it may have encountered increased resistance where the amperage will be less. So just be mindful as you look at the relationship between these four channels. If we ever had a situation where we had intermittent cooling, that's why I kind of picked these four channels to see. As far as the pressure, I think I've seen situations where expansion valves, orifice tube, in particular expansion valves, will stick now and then. When they stick closed, they create a situation where the pressure would get too low. If they stick open, you wouldn't get the good low pressure on the low side. So just be mindful of that something, whatever the medium is that changes the high side to the low side, whether it be a expansion valve, an orifice tube, an H block or something, it could have a tendency to stick or something and affect the outlet, the temperature, and the pressure. So we're going down the capture, and we'll get back to the normal. We go to the second one, and basically we can see action here. Our pressures, our AC is giving it some RPM. Our AC pressure is going down. Compressor's turning faster. As you can see that, we're going from about 26 psi, and we get down to about 11 psi, and then our AC disengages, and you can see our pressure going up. We can see our voltage going away from the compressor, and we can see our current obviously following the voltage, which tells us that we don't have current flowing to the AC clutch. And it looks like our evap temperature sensor is going up. On the left side of the capture, it was about 3.2 volts. On the right side, it's gone to about 3.7 volts. So that's basically the fluctuation of that temperature sensor is important for the AC control head to know, because a lot of the outputs are determined based on that input temperature from that sensor. So as we go down the line, we see some more action. Basically, we see the same thing: AC temperature, evap temperature going down, AC pressure going down. Clutch just kicked on here, and we can see a good pull down on our pressure transducer where the pressure is descending. We see our pintle hump. Our clutch got engaged. It got fed its voltage from the AC relay, which is controlled by the PCM. And nonetheless, I'll continue to go down through the capture. This is a disengagement here. We see more action, and we see an engagement. We see another engagement here, a disengagement. Basically, I know don't want to sound like I'm a broken record, but nonetheless, just get the idea of the relationship of these signals. If you're ever chasing a intermittent cooling issue, where it may not just be I was gonna say cold hard failure, but no pun intended, but something where it just stops working and you deal with it and you do your diagnosis in the bay right there. But this is one that would cool and not cool and cool, and then these are pretty good scope captures and to determine if that could be happening. I realize the scope, as I said, the hookup may be a little time consuming for this, but nonetheless, if you ever had a situation where scan data was not good enough and you needed this is a real powerful way to look at the AC system. So let's continue to go down. We can see this. Anyway, that's just another capture of the AC kind of short cycling. And then I came to a halt at the end of the capture, and you can see it right here. Basically, okay. So anyway, this is Technical Technician from Diagnation signing off, and hope you enjoyed the video. Take care.